Hello my students, that's part 2 of Unit 1 Edexcel Board October-November 2023 paper. The first question is this question about the elements in the period 2 of the periodic table. The first ionization energies of the some elements in the period 2 are shown. Okay, you will see first ionization energy in kilojoule per mole. Explain the general trends in the first ionization energy across the period. You can see that you have two marks. Okay, now why or the trend in the first ionization energy across the period, it looks like that. Across the period, there are some important points about the ionization energy across the period. Okay, you will see that the atomic radius decreases. The atomic radius, it decreases, so the electrons are closer or the electrons are more attracted. Electrons are more attracted by the nucleus. So this means that higher energy was needed to attract the electrons. So the ionization energy increases across the period. So across the period, ionization energy increases. That's because the atomic radii decrease and the attraction force between the nucleus and the electrons was higher. So the general trend is the increase in the ionization energy. He's asking you to predict the first ionization energy of oxygen and justify your answer. Okay. Now for oxygen, you shall return back to 3 electronic configuration in the table which is given in the question. We have the nitrogen, oxygen, and a fluorine. Let me do something. Okay. Maybe. Now, you will see for nitrogen, the electronic configuration for nitrogen is where the atomic number is 7 for nitrogen, and for oxygen it is 8, and for fluorine it's 9. Okay, you will see. Let me explain this. There. You have nitrogen, you have nitrogen, oxygen, and fluorine. For the nitrogen, it's 7. For oxygen, it's 8. And we have 9 there. To find or to predict the value of oxygen, you should return back to the electronic configuration, 1s2, 2s2, 2p3. Here you have 1s2, 2s2, 2p4. And here you have 1 S2, 2s2, 2p, what? 2p5. Now, for nitrogen, the p orbitals has 3 unpaired electrons, while for oxygen we have 1, 2, 3, and the fourth one is paired. So the value of the ionization energy of oxygen, it will be lower than nitrogen. And the value of 2p5, it will be higher than what? Than oxygen. So this means that the value of the oxygen ionization energy will be lower than nitrogen and lower than fluorine. So it will decrease for oxygen, then it's coming to the higher value for the fluorine. Okay? So this value will be lower than fluorine, lower than nitrogen, and also it's lower than fluorine. So it will be like 1,382, for example, or any value which is lower than, little bit lower than the nitrogen, but it's also lower than fluorine, and the fluorine will be in a higher value. Okay. Now, the explanation, as I said, because it has a paired, while for fluorine it has a higher attraction force within the more attracted or with the higher nuclear charge, so it is more attracted to the nucleus. Now, what's next? The second ionization energy of lithium, Li, is 7,298 kilojoule per mole. Write the equation for the second ionization energy of lithium, includes the state symbols. You will see lithium is positive charged first in the gaseous state, and the second ionization energy is to knock out the second electron from the unipositive ion, okay, plus electron. That's the second ionization energy. The 2 marks are for the correct formula and for the correct charge and the gaseous states or the states symbol. Now, explain the large difference between the first and the second ionization energy of lithium. Okay, here you shall return back to the electronic configuration of each ion, okay, because this will clarify it will clarify, or it will make the idea clear. Because if one electron is lost from the structure, this means that the electrons are in a new shell, and this will give us a new idea about the electrons. So the second electron is removed from a lower ionization energy. So Li has the atomic number 3, and Li positive 1, Li has one S2, two S1, while the Li positive, it's only one S2. You can see that this one is closer to the nucleus, so it requires larger energy. So what we can write, you can draw the electronic configuration of the elements, and in lithium positive 1, the electron is removed from 1s2 compared to 2s1, which requires a higher energy to overcome the stronger attraction force with the nucleus. Okay. Now, the next idea is, or the next question is about beryllium reacts with the chlorine to form beryllium chloride, and in the gas phase, beryllium chloride exists both as simple molecule and as a dimer. Okay. Now you will draw, he's asking you to draw the dot cross diagram for the beryllium dichloride. So beryllium is present in a group 2. So it's BeCl, it's a molecule. So we can draw something like that. Okay. Or you can select X if you want for chlorine, it's okay. Now we have 2 X's, we have 6 electrons surrounds the chlorine. That's why we have the beryllium chloride dot and the cross diagram. Or sometimes some students, they draw it like that. So we have beryllium, and there is a kind of sharing, okay, sharing of electrons. That's the idea. Both methods are correct, or both ways are correct. Now, explain the shape and the bond angle in the molecule beryllium dichloride. Since we have 2 bonded pairs, so the shape is linear, and the bond angle is 180 degrees. The explanation to minimize the repulsion between what? 2 bonded pairs around the central atom. Like that, we use the terms of Bishr theory, valence shell electron pairs repulsion theory. Okay. Now, for next question, draw a diagram to show how beryllium chloride molecules bond together to form a dimer. Okay, you can see that. Here we have beryllium chloride and beryllium chloride. Okay, so you will see that each chloride here, the chloride can form a bond with its linear one. So here we have beryllium chloride, another beryllium chloride, and here we have beryllium chloride. You will see that this one is donated, so this means that we have like this bond, Cl, 2 electrons was donated there, and 2 electrons was donated there. And what is left is, you can see that's the dative covalent bond, and that's the dative covalent bond. And here we have 2, 4, 6, and 8. And here you have 2, 4, 6, and 8, while the others are still the same. So that's what is known as dimer, the 2 marks for 2 dative bonds from 2 chlorine in different molecules. That's the dimer. Type of bonding, as I told you, it's dative covalent bond. Okay. Now, the next question, 19. Many cars use fuel containing ethanol as well as hydrocarbon. The E number of these fuels show the percentage by volume ethanol in the fuel. For example, the E5 fuel contains 5% ethanol and 95% hydrocarbons by the volume. The brand of E10 fuel contains 92.2% hydrocarbons and 7.8% ethanol by mass. The energy density is the amount of energy released per kilogram of a fuel burned, and the energy density of the 2 components of this brand of a fuel are shown. The energy density of the hydrocarbon and the energy density of ethanol. Calculate the mean energy density of this E10 fuel in millijoule per kilogram. So give your answer in the appropriate unit and in significant figures. Okay, so this can be done by, for hydrocarbon, it is 92.2%, and its percentage energy density of the hydrocarbon, and this is the percentage. And for ethanol, it's 29.7 and 7.8. So it is done like that. Only multiply these numbers like when you calculate something for the isotope. So you can take the 92, okay, 92.2 times the 46.5 plus the second one, which is 29.7, okay, times 7.8, and this is over 100%, and we got the answer, which is 45.19. So for significant figures, it is 45. This is the average unit density for the fuel. Now, the density of E10 fuel is 0.729 grams per cubic centimeter. Calculate the mass of 1,500 or 1,500 cubic centimeter of fuel. So that's very easy. The density equals the mass over the volume. So from this formula, you can find that the density or the mass equals density times volume. That equals 0.729 times what? 1,500. This gives you the mass of how much? It is 1,093.5 grams. Okay. Now, next idea is calculate the energy released when 1,500 of cubic centimeter of E10 fuel is burned in excess oxygen using your answer from EI and E2I. Okay, that's the mass. And we calculate that 45 millijoule was calculated. So we can calculate how much we have. It is 45. Do you remember? It's 45 point how much? 0.19 millijoule. Okay, that's in AI. Now to find the kilogram per kilogram, the mass that we find is 193.5. This is over 1,000. This will give us the mass of, this is the mass, which is 1.0935 kilograms. So to find the answer, just multiply 45.19 times 1.0935. So this will give you 49.415 millijoule. So this equals 4.9 4.9415 joules. Okay. Times 10 to the power 7. So the final answer is, when you megajoule, sorry, it's not millijoule. The megajoule is let me find the correct answer. The correct answer is equals 4.9415 kilojoule, or it is 49.415 megajoule, which is 4.9415 times 10 to the power 7 joules. So it's around 4.9 joules. Okay. Many countries are generally or gradually, replacing E5 fuel with E10 fuels. Explain how this change might result in more sustainable fuel. Okay, you can see increase in the amount of the fuel or ethanol, okay, from the fermentation. It will, and the fermentation process which causes which is from the glucose or the fruit sugar, and in overall this will reduce the emission of carbon dioxide, and like that there is a lower global warming. From the question itself, we saw that E10 contains more ethanol, okay, and since it has more ethanol, this means that it comes from renewable source of energy, and burning the ethanol causes lower emission of CO2 that cause the global warming. 3 points of this will give you the correct answer, or it will give you the total marks for the question. The straight chain alkane hexane can be reformed. Give the range of the product. It was suggested that such reaction may produce cyclic hydrocarbon and hydrogen gas as the only product. The cyclic hydrocarbon contain a ring of 5 carbon atoms. Write the equation for this reaction using a molecular formula. State symbols are not required. So it is hexane C6H14. It is cracked to C6H12 plus H2. Now he's asking you to draw the structure of the cyclic hydrocarbon. So the structure of the cyclic hydrocarbon contains 5 rings. So that's it.